Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video, we are going to learn about decision trees. These algorithms, decision trees, these sets of algorithms, decision trees are very simple algorithms from the perspective of the person who's using them. However, there are many details and delicacies that from the aspect of creating it that someone who really needs to understand decision tree, they need to understand. In this video, we are going to raise the hood and see what's going on behind the decision tree, the way it's created and the way it's inducted. And I don't think this is going to be only one video, so it's going to be at least 2-3 videos that we are going to discuss different aspects of decision trees. So in this video, in the first video, we are going to only focus about, how in a general sense decision tree come to be. The main, the blueprint, the main aspects of the underlying works that happens for the decision tree to happen, basically. So let's look at this next. Alright, so in this video, after a few recap, we are going to discuss different elements of a decision tree, and then we're gonna see what is an induction algorithm for decision tree, which is that blueprint I was just talking about. And then also what is purity, a very important concept for creating decision tree, and then attribute selection method. And of course, we're gonna wrap things up with a summary in this video. So one of the first things that we need to understand when we discuss decision trees is the fact that decision trees can handle both classification and prediction. However, historically, decision tree was created for classification, and then later on it was adjusted, tweaked so it can handle prediction too. So in this video, we're going to focus on the classification aspect of it, but in one of the future videos, we're going to discuss the prediction aspect of it too. I mean, it's called decision tree regressor. We'll talk about that in one of the videos. So it can, handle both classification and prediction. All these tasks are, as we've been repeating over and over again in these videos, is this, connection between independent attributes and the dependent attributes. These are the algorithms that do that, classification and prediction algorithms. And decision tree is going to do this as well. And we do know that if, this dependent attribute is categorical, this is classification. And if this is, numerical, then this is prediction. So in this video, we're going to talk about the classification one. So a decision tree is really one of the most popular classification algorithms, and the reason is it's very transparent. I mean, the person who's going to use it, they don't need to know anything really. I mean, it's just a very transparent, branch-like decision tree that you say, okay, if this attribute is this value, then your prediction is going to be this value, and it's really good for sort of seeing the patterns in the data and those patterns that relate to the supervised learning of this independent attribute trying to predict the dependent attribute. So that's the decision tree, and the difference between decision tree and KNN and naive Bayesian, in which we discussed in the previous videos, KNN and naive Bayesian are both lazy algorithms, meaning that whenever you want to do a prediction of a class of a data object, you basically start in that moment and say, okay, now let me go look at the data, and then it would come back with a yes or no for each of these data objects that we don't know its class, right? So this is done one by one. So it goes from, it takes one of the data objects and goes and come back with a yes or no. But decision tree is a eager algorithm, meaning that it takes its time to learn, right, from the data, right? So it doesn't even look at what are the data objects it wants to predict. It just said, okay, I don't want to look at what are the data objects. I'm just going to go learn on my own from the data. And then once I'm ready, I'll be able to give you the yes or no for these data objects. So that's the difference between eager and lazy algorithms. So this is an example of a decision tree. You can see, for example, in this example, we've got 3 independent attributes, right? So these are 3 independent attributes, and we've got 1 dependent or target. So here you can see, for example, if education level is master's, then we are predicting our target. And then if it's bachelor, we have to look at the customer income, So you have a tree-like, very simple tree-like decision making that it's been created by having gone through this data, right? So this is what the end result looks like. So we're kind of starting at the end, so we understand what it is, and then we'll see how this has came to be. So a few things one thing to learn before we move on is the fact that, do you remember what we said about this connection, right? So that's this connection, right? So this is what we are trying to do here, and that's tree-like that we just saw here, right? This, tree-like structure is this way for the decision tree to connect these attributes, right? So that's what's happening here. We are creating a tree-like structure to connect the independent attributes to the dependent attributes for the task of classification. So let's learn about what are these elements are called. These are called split node. The triangle ones, meaning that it's going to split the data, right? And these are called leaf nodes, meaning that it's the end of the decision tree, something like it's a leaf. It's sort of like the product of the decision tree. So the split nodes are the one that denotes a test on your data, meaning that it's going to split your data from, a larger set to smaller sets. And the leaf nodes are the one that says, okay, it's a class label 1 or label 2, yes, no, 0, 1. This is the one that, it does the tell us what's going to be the class. And we've got one root node, which is the very first split nodes, which is this one. This is the root node. All right, so now let's talk about the induction algorithm. It's a blueprint of any decision tree algorithm. It's the main structure. You can see it's very simple. It's basically start with the data, and if the data is not non-empty, it's kind of obvious. That's why I have it in gray. If the data is non-empty, so it continues. Then it basically split the data one by one by looking at one of the attributes. Split it one by one, and then sees if there are, are there all of the data objects in this split of the same class or not. If they're not the same class or not, it means that we need more split. So that's how it happens. It keeps splitting the data in such a way that at the end, all of the data objects that are at the branches of these, the splits, gets to become pure, or all of the classes are the same. So that's basically the induction algorithm. Let's look at how this is done, from the perspective of the induction algorithm on this data set. So first of all, we have to decide if this is going to be a split node, or a leaf node. And we do see that it's the first one, of course, going to be the root node, which is the split node. But at the same time, we do see that we don't have only cases of yes or only cases of no. Therefore, this has to be a split node, right? So it's a split node. Pay attention to the change from the circle to the split node. So once we decide it's a split node, then we have to choose an attribute to split the data by, right? Let's say we choose education level for some reason, right? And that reason is an attribute test that we will discuss in this video. But let's continue. I want to sort of get to the end and then come back and see what this attribute test is. There is a mechanism which is called attribute test that chooses this education level. And we're going to talk about that mechanism. But let's say it's an education level, and then once we get to this education level, which have 3 possible states, it has, high school, it has bachelor or master's, right? So these are the 3 possible states. And we have to split it. And there are all these possible splits. You can split them from master, bachelor, high school, or you can split it from master, bachelor, high school, master, bachelor, high school. And any of these are possible. But why is this not possible? Master, high school, bachelor. Think about this for a second before I give you the answer. Of course, the reason is the education is a ordinal attribute, right? So we've got high school, bachelor, and master, right? So there is this ordinal relationship with them. But what's happening here is that we've got master and high school, and then bachelor. So it kind of doesn't make sense because this is an ordinal attribute. That's why we haven't included that one there. But anyway, among all the possible ones, we choose this one just because it leads to better separation between our, class labels or our target. Like we have all the no's here and all the yes here for masters. So it gives us a really good filtering of our data for the purpose of the classification. And because of that, we choose this one. So we choose this one, and then at each of these nodes, we are going to again do the same thing, right? So now we have a new node here. We decide in the new node here, we have to decide if this is a split node or a leaf node. And when we look at all of our data that comes to this node after this filtering, all of them are no, right? So there is no reason for any more splitting. Therefore, this is a leaf node. And we call every data object, any data object that comes here, which means everyone whose education level is high school, in this data set, they didn't pay their loan. So that's why we sort of call this a leaf node and we call this a node. And then another one, this master, all of the education is a master. We look at all of the data objects, or they are of yes. This is another leaf node, so we call it a yes. And then we come to this one, which is another node that we have to check if it's a split node or a leaf node. And when we look, we do see that we've got cases of yes and we got cases of no, right? So this has to be a split node, right? So we make that change. Pay attention to here. This changes. So we've got that split node. So now we have to do this all over again. We have to select an attribute. We have to do an attribute test, and we have to go through these list of attributes, and then based on that, let's say again based on attribute test, we choose this one, which we'll discuss. What's that? How come we choose that one? We chose education level. Let's say we choose this one, and then we have to split, and we do find that this is the best split at 72.5. Pay attention, this is the number between these two, right? So that's where that comes from. So we say this is the best split, and then we split the data, and everything here is going to be no. So this is a leaf node, and then we check here, we still have yes and no. So this is going to be still a split node. And of course, there is only one attribute, which we choose that one, and then we see if we split it between 5 and 6, which is 5.5, then we also get more purity or more, one of the nodes going to be split, so it's going to be yes. And this one, there is no reason to, move further along than this, so we just sort of call this a no. Because this is a yes, we call this, we make a judgment call. And this is not, with the definition of leaf node is not a leaf node, but instead of like, you know, making this a split node and like having a, you know, larger tree, let's just make it at this point, make a judgment call and call this a split leaf node. So that's what has happened. All right, so this is our, you know, quote unquote trained decision tree based on our data, right? So we went through the data. Our decision tree is an eager algorithm. Eagerly, it learned from the data. Now it's ready to look at all those you know, data objects to sort of like go through this and start making decisions. So as I promised, we kept referring to this attribute test, and now here we're going to have the opportunity to see what it is. An attribute test does two things. It basically chooses the splitting attribute. Do you remember we chose first education level and then we chose years in current job? I believe, let me see which one did we chose. Then we chose customer income. So those are the first thing that attribute test does for us. And then also it is in charge of making sure to choose what is the best split possible for you know, that specific attribute we have selected. And the goal is for us to have the branches that are as pure as possible. So that's the goal of attribute test. So let's sort of look back and see what that means. But before that, let's talk about what is the purity. This is a very important concept in decision trees and perhaps in classification algorithms, is that a node is pure if all of its data objects are of the same class. And you know, we sort of like have this spectrum of you know, it's a definition of a spectrum of like purity. I mean, you have fully pure, completely not pure, and things in between. And sort of that helps us to sort of like numerify or codify how pure branch is, or how pure is a filtered part of the data is, right? So, for example, which nodes here are pure, right? You know, we remember that all of the leaf nodes that we looked at, except for this one, they were all pure. Just to practice, you know, just look at these, you know, come all the way to each of these nodes, and you will see the only possibility for you know, for one of these data to be of those nodes are going to be either no or yes. So those are the pure nodes. To codify or, you know, sort of like capture this concept of purity, there are a few metrics: information gain, gain ratio, Gini index, CSEP, and GS statistics. All of these are, you know, possible purity metrics, and you know, we actually work with some of them in, you know, when we tune a decision tree. So we have to sort of like select the best one. But you know, for the purpose of just learning what it looks like, we're just gonna like cover one of them, which is the Gini index. So we're going to just cover the Gini index. The Gini index basically is you know, sort of like calculates the impurity of a metric, a data set. And if the impurity is calculated, then you know, it's sort of like, you know, the opposite of purity, so we can sort of use it for purpose of the attribute selection or attribute test. So M here is the number of cases, number of classes. So for our example, we had yes or no, right? Do you remember? So M is equal to, and PI is the probability that an object in D belongs to class CI. So I mean, once we look at an example, which we will do right now, it's going to make much more sense. So here we've got the 1 minus the probability of yes power to 2 minus probability of no power to 2, right? So 1 minus 9, which is the number of yeses, 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by the total number 16 minus 7, which is the number of no's, 1, 2, 3, 4, 5, 6, 7, divided by 16, right? So this is an example of sort of like calculating the purity or actually impurity of this whole data set, right? So that's the Gini index, very simple. For example, now let's discuss how did we come to education level. All we did here was to calculate the possible, purity each of these three attributes could bestow us, right? And since education level was able to create more purity, or sort of like diffuse more impurity, or like so get rid of more impurity, therefore we choose education level. So that's all there is to it. But let's sort of look at the calculations here, right? So the calculations a little bit look different for the categorical attribute and the numerical attribute. For the categorical attribute, we sort of like look at all the possible sort of like separation or like filtering the data based on the categorical attribute, and we choose the one that is best. For the numerical ones, we actually have to find that point, find that cut point. That we will see how we do that. So, for example, here we've got the calculated the impurity of this this separation. If we were to do this separation, how this would look like. So here we've got we lead to three sort of like data sets, or like subsets of the data, and we calculate the impurity for all of them, right? So this is its impurity is 0, as we saw here, right? The high school. So this is high school, this is bachelor, and this is master, right? And for the master, it's also 0, as you can see. And for the bachelor, the impurity is the highest it can be, 0.5, right? Based on the Gini index. And then we do a weighted calculation, because we've got 3 high school, 3 over 16 multiplied by 0, and then 5 over 16 multiplied by 0, and then we've got 8 over 16, which is 1 over 2 multiplied by 0.5. So overall, the impurity will decrease to 0.25 if we were to do this one, right? And this is sort of the formula we used here. This is the the weighted average of the Gini indexes for all of the sort of like subsets that this test or this splitting of the data leads us to, and that's how we use it. And this is the formula which I discussed already, but it's very simple. Let's look at an example instead of going over this formula. So for example, I'm going to do the same thing here. So we have to calculate the Gini index, right? Gini index for high school, which is going to be very similar, 1 minus the probability of no, and we are just going to look at this one, right? The probability of no is going to be 3 over 3 power to 2 minus 0 over 3 power to 2, which is going to be 1 minus 1, 0, right? And then we have to calculate the Gini index of master and bachelor, which is going to be 1 minus, now we have to see how many data objects we have. 16 minus 3 is going to be 13. So let me go ahead and do this. And now how many no's we have? 1, 2, 3, 4, 4. And then how many yes we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. And we calculate this, and after that, whatever this is, we have to calculate the weighted, which is the Gini index of this split. This whole split is going to be 1 over 3 multiplied by 0 plus this multiply it's 3 over 16, and this is going to be 13 over 16, right? And then we get an answer, right? So I've got the calculation here. You can see sort of like they're the same thing, but we also have the answer, right? So let me just wipe these out so we can see the answer. And the answer is this one. And then we do the same thing, similar things here, and the the impurity value or the Gini index is going to be this value. And once we have done all of the possibilities, then we sort of like say, okay, this is the best possible one that we can reach for education level, right? So let me like remind you where we are. Let me go back a little bit. So now we calculated the possible Gini index for this one. Now we are going to calculate for another one and then for another one and see which one is going to be the best. So here we so far got this, that it can reach us to this Gini index. So now we move to the customer income numerical attribute. Like I said, for the numerical attributes, we have to also find that cut. And the first thing we do, we sort our data. Pay attention, it's been sorted by customer income, right? We sort our data by customer income, and then we experiment with different cuts. If our cut were going to be here, this is going to be the impurity of the split. If the cut were here, this would be the impurity of the split. The cut were here, this would be. So we just do experimentation, and it seems to be the best one. And yeah, so this was the best cut. I mean, we just are doing the experimentation here. And we do the same. So out of all of this is the best one. And we do the same thing for the years in current job. And this is the best one actually. I mean, I haven't shown this here. This is also ordered by the sorted by years in current job, and this is the best one for that one. And then eventually, do you remember for education level it was this one, for customer income was this one, the Gini index and the years in current job was this one. Therefore, because this is the leads to the least impurity or highest purity, this is the one we choose, right? So that was the process of choosing education level for the first sort of split now. So that's how we learn, and we do the same thing. Continue. Let me go back here, right? We keep doing the same thing. So we got here, and then here we have to again do the attribute test. Here again, so we keep doing the same thing until our tree is completely inducted and we've got the whole tree. There are more to be said about decision tree, and we're going to still continue talking about decision tree. But right now, you have a pretty nice understanding of from a blueprint perspective, like general understanding of what's under the hood or what's behind the scene. We have a better understanding of how decision tree works. So let me wrap things up with a summary. So in this video, let me get there. We talked about how the decision tree work, and then we talked about the very important concept of purity, and also we talked about the attribute selection method or the attribute test that would basically decide what attribute do we use to split the data further. All right, until the next video.